Imagine this. Right now, as you're watching this video, 40 light years away from Earth, there's a world with blue skies, with liquid water flowing across its surface, with temperatures that would feel comfortable, not too hot, not too cold, just right. For 70 years we've been searching, scanning the cosmos, pointing our telescopes at distant stars, hoping that somewhere out there we're not alone, that there's another pale blue dot floating in the darkness. And now, after decades of false alarms and maybes and almosts, we found it. The hunt is over. Stay with me, because what I'm about to show you isn't science fiction. This is real, this is happening, and the implications, they're going to change everything we thought we knew about our place in the universe. To understand why this discovery is so monumental, we need to rewind a little. We have to go back to an obsession that has driven humanity for generations. It all started in 1961. A scientist named Frank Drake stood in front of a chalkboard and wrote down an equation. This wasn't just any equation. It was the one that would haunt astronomers for the next 6 decades. The Drake equation. It was a simple question. Really, how many intelligent civilizations exist in our galaxy? But to answer that, you first have to answer something even more fundamental. How many planets like Earth even exist? And for 40 years we didn't know. We couldn't know. Our telescopes weren't powerful enough. Our technology wasn't sophisticated enough. We were essentially blind, staring up at the night sky, just wondering if any of those twinkling lights had worlds circling them. Then, 1995 happened. 2 Swiss astronomers, Michel Mayor and Didier Queloz, detected the first exoplanet orbiting a sun-like star. And just like that, the floodgates opened. Suddenly we realized planets weren't rare. They were everywhere, trillions of them, scattered across the galaxy like cosmic confetti. But here's where it gets interesting. Finding planets, that became the easy part. Finding planets like Earth, that's where things got complicated. See, most of the planets we discovered were nothing like home. We found gas giants larger than Jupiter, orbiting so close to their stars they were literally being cooked alive. We found frozen ice worlds in the outer reaches of solar systems. We found planets made of solid diamond, planets where it rains molten glass sideways, planets so bizarre they seemed ripped from a fever dream, but an Earth twin. That was the holy grail. And finding it required something very specific. Scientists call it the Goldilocks zone, that perfect distance from a star where temperatures are just right. Not too hot that water boils away into space. Not too cold that everything freezes solid. Just right for liquid water to exist on the surface. Because where there's liquid water there's a chance for life as we know it. In 2009, NASA launched Kepler, a space telescope with one mission: find Earth 2.0. For 4 years, it stared at 150,000 stars, watching, waiting, looking for that tiny telltale dimming of starlight that happens when a planet passes in front of its sun. Kepler found thousands of planets, thousands, but the perfect twin remained elusive. Until now. This is the discovery that changes everything. Now, you might be thinking of K218b. That was exciting back in 2019 when we detected water vapor in its atmosphere. But it was too big, too massive, not quite right. What I'm talking about is something new. Something that just emerged from the James Webb Space Telescope, humanity's most powerful eye in the sky, launched in 2021. The planet is called LHS 1140b. Now, I know what you're thinking. That's not a very catchy name. You're right. But what this planet is, that's where your jaw should be dropping. LHS 1140b orbits a red dwarf star about 40 light-years away in the constellation Cetus. It's roughly 1.7 times the size of Earth. And here's where it gets wild. New data from the James Webb Space Telescope, combined with observations from other instruments, has revealed something extraordinary. This planet sits perfectly in the habitable zone. The temperatures, between 20 and 30 degrees Celsius at the surface, that's 68 to 86 degrees Fahrenheit, beach weather, hoodie weather, our kind of weather. But temperature alone doesn't make a planet Earth-like. You need an atmosphere, you need water, you need stability. And this is where the new data from Webb is sending shockwaves through the scientific community. It suggests LHS 1140b is not a gassy mini-Neptune like so many others, but a dense, rocky world, possibly with a substantial ocean. The evidence points to an atmosphere that is thick enough to protect the surface but not so thick that it creates a runaway greenhouse effect. We're talking about a world that's not just in the right place but has the right ingredients. It's a stable, temperate, rocky world with the potential for vast amounts of liquid water. This isn't just another dot in the sky. It's the most promising Earth-like world we have ever found. The search for a second Earth isn't science fiction anymore. We might be looking right at it. The next steps will be to analyze its atmosphere for biosignatures, the chemical fingerprints of life. And for the first time that feels less like a long shot and more like an inevitability. So what's the smoking gun? What's the undeniable evidence that finally changed everything? It all comes down to spectroscopy. This is a fancy way of saying scientists can break down the light that passes through a planet's atmosphere to see what it's made of, and what they found was truly remarkable. They detected a nitrogen-rich atmosphere, just like Earth's, but it gets even better. They also found water vapor. And we're not talking about just tiny traces. They found significant amounts. The scientific models now suggest this planet could be what we call an ocean world. I want you to picture this for a moment. A planet where a staggering 20% of its total mass is water. To give you some context, all the water on Earth makes up less than 1/10% of our planet's mass. Now, imagine an ocean 4,000 kilometers deep. That's like stacking the Mariana Trench on top of itself 300 times. Beneath this immense global ocean is a rocky core, and above it, a breathable atmosphere. And here's the real kicker. This planet LHS 1140b is tidally locked. That means one side is in permanent daylight, always facing its star, while the other side is in perpetual darkness. But right there in the middle, along the line where day meets night, what scientists call the Terminator line, there's a special zone, a habitable ring that stretches around the entire planet, where temperatures are stable and moderate. It's here that liquid water could pool, and it's here that life, if it exists, would have its best chance to thrive. The scientists running these observations are calling it the most promising candidate for habitability we have ever found. Not might be, not could be the best candidate. Dr. Charles Cadeo, one of the lead researchers, said something that gave me chills. He said, "This is the first time we've observed an exoplanet with an atmosphere that resembles Earth's, in the habitable zone, with conditions that could genuinely support life. But wait, there's more. Because what makes this story even more incredible is that LHS 1140b isn't alone. The James Webb Space Telescope has only been operational for just over 3 years. In that short amount of time, it has already identified multiple other candidates that meet the criteria for being an Earth 2. There's TOI 700e, another planet confirmed to be in its star's habitable zone, with atmospheric signatures that suggest stability. Then there's Proxima Centauri b, orbiting the closest star to our own Sun, just 4.2 light-years away. Updated models suggest it might have held on to its atmosphere after all. And we can't forget TRAPPIST-1e, one of 7 Earth-sized planets orbiting a tiny red dwarf star, with new data hinting at a retained atmosphere and possible water. The evidence is piling up, faster than ever before. And it's all pointing to one inescapable conclusion. Earth-like worlds aren't rare. They're actually quite common. Statistically, there could be billions of them right here in our own galaxy. The hunt isn't just about finding one other Earth anymore. It's revealed something far more profound. We're not special because we're unique. We're special because we're the first to discover we might not be alone. None of this would be possible without the James Webb Space Telescope, and it's really worth taking a moment to appreciate just how insane this machine is. It's sitting right now at a special point in space called L2, about 1 million miles from Earth, held in a perfect gravitational balance between our planet and the Sun. Its massive mirror is 21 feet across, made of 18 hexagonal segments, each one coated in a thin layer of pure gold. This isn't just for looks. Gold is incredibly effective at reflecting infrared light, and that's the key. Webb observes the universe in infrared, seeing wavelengths of light completely invisible to our eyes. Why is that so important? Because with that incredible capability, it can detect the chemical signatures of atmospheres on planets trillions upon trillions of miles away. Think about that for a second. It can tell us if there's oxygen, nitrogen, methane, or water vapor on a world we'll never touch. It can essentially smell the air of another planet from across the vast cosmic ocean. That is mind-bending technology. When the James Webb Space Telescope launched on Christmas Day 2021, scientists had a huge wish list of discoveries they hoped to make over its 10 to 20-year mission. But finding a true Earth 2.0, a rocky world with a thick atmosphere and liquid water, was right at the very top. They thought it might take a decade, maybe longer. It took them 3 years. So, the big question is, what does this all mean for us? What now? Well, here's the reality check. LHS 1140b, this incredible new world, is 40 light-years away. That distance is almost impossible to comprehend. If we sent a message today, traveling at the speed of light, the absolute fastest speed possible in the universe, it would take 40 years just to get there. And then, if someone or something was there to reply instantly, it would take another 40 years for their message to get back to us. We're talking about an 80-year round trip for a simple hello. And as for visiting, let's just say it's not on the cards. Even our fastest spacecraft, like the Parker Solar Probe, would take hundreds of thousands of years to make the journey. So, we're not packing our bags for a trip to LHS 1140b anytime soon. But that's not really the point, is it? The true significance of this discovery isn't about interstellar travel. It's about something far more profound. For the first time in the entire history of humanity, we can point to a specific tiny dot in the night sky and say with real, hard scientific confidence, there, right there, that is a world like ours, a world where rain might fall from clouds, where waves might crash against a rocky shore, where mountains might rise into a hazy sky, a world where maybe, just maybe, something is looking up at its own night sky, at a tiny yellow star in the distance, and wondering the very same thing we've wondered for millennia. Are we alone? And now, for the first time, we have the beginnings of an answer. The math, the evidence, the sheer overwhelming probability of it all, it's all pointing in the same direction. Life might not be a rare miracle. Habitable worlds might not be one in a trillion exceptions. What's been rare is our ability to find them. And now we're getting really good at it. This isn't the end of the search. It's the beginning of a new chapter in our cosmic story. In 1990, the legendary astronomer Carl Sagan had a brilliant idea. He convinced NASA to turn the Voyager 1 spacecraft around, one last time, for a final family portrait. From nearly 4 billion miles away, it captured an image of Earth. Our home was just a tiny speck of light, a mote of dust suspended in a sunbeam. Sagan called it the pale blue dot. In his book, he wrote something that still gives me chills. He said, "On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. All of human history, all our triumphs and tragedies, played out on that tiny pixel." It's a powerful, humbling thought. It puts everything into perspective. Right, but here's where the story takes a mind-bending turn. For Sagan and for everyone at that time, Earth was the only pale blue dot we knew. It was our singular stage in the vast cosmic arena, but now, things are different. We've discovered that our pale blue dot is not alone. The universe is filled with them. We're talking about other worlds, orbiting other suns, that might just have the right conditions for life. Maybe they're home to simple microbes, living out a quiet existence in alien oceans. Maybe they host intelligent civilizations, with their own histories, their own art, their own Carl Sagans looking up at the stars. Maybe their story is just beginning. Or maybe they've been around for billions of years, long before life even started here on Earth. We don't have the answers yet, but for the very first time in the history of our species, we have the ability to find out. We're not just guessing anymore. We have the technology, like the James Webb Space Telescope, to peer into the atmospheres of these distant worlds. We have the evidence, mountains of data pointing to planets in the habitable zone of their stars. And we have the coordinates. We know exactly where to look. Take a planet like LHS 1140b. It's a super-Earth about 40 light-years away. It's rocky. It's in the habitable zone of its star, and scientists believe it could have a significant atmosphere and even vast oceans of liquid water. Think about that, a water world, just waiting to be explored. The search for a planet that looks like Earth, and Earth 2.0, is arguably over. We've found multiple candidates. The real hunt, the next great adventure for humanity, is just beginning. The search for what or who is on them. So tonight I want you to do something. When it gets dark, step outside and look up at the night sky. Find the constellation Cetus if you're in the northern hemisphere. You can see it during the autumn and winter months. And as you're looking in that direction, just take a moment to think. 40 light-years away, in that patch of sky, is another world. A real, physical place with its own sunrises and sunsets. Maybe with clouds drifting across its skies and waves crashing on its shores. A world with conditions that could mirror our own. And somewhere out there in the universe, maybe on that world, maybe on another one of the countless pale blue dots, someone might be doing the exact same thing. Looking up at their sky, at a faint speck of light that is our sun, and wondering we are living in the age where we've found them. The profound question now is, what do we do next? If this idea blows your mind as much as it does mine, make sure you hit that subscribe button. We are in a golden age of discovery, and you won't want to miss what comes next. What do you think we should do? Should we actively try to send a message to a world like LHS 1140b, announcing our presence? Or should we just observe from a distance, listen quietly, and learn? Let me know your thoughts in the comments below. I promise I read every single one. Thanks for watching. And always remember, the universe is far stranger, far more beautiful, and far more full of possibility than we can possibly imagine. Until next time, keep looking up.